Hi everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 24. The below figure shows three fixed charges on a coordinate system along with their coordinates and charges. Before solving the problem, if we label the charges as 1, 2 and 3, then Q1 is negative 4 nanocoulombs, where 1 nanocoulomb is 1 times 10 to negative 9 coulombs. The distance between Q1 and the origin is R1, which is 4 centimeters. Q2 is negative 3 nanocoulombs. And the distance between Q2 and the origin is R2, which is 3 centimeters. Finally, Q3 is 5 nanocoulombs, and the distance between Q3 and the origin can be found by the Pythagorean theorem as 5 centimeters. Now let us look at the problem. A. Relative to infinity, calculate the electric potential at the origin due to these three charges. Relative to infinity, where the potential is 0, the electric potential at the origin due to charge Q1 is K times Q1 over R1. And because of charge Q2 is K times Q2 over R2. Finally, due to Q3 is K times Q3 over R3. The constant K is common in all terms. Therefore, we can write K times Q1 over R1 plus Q2 over R2 plus Q3 over R3. At this point, we can substitute the numerical values into this formula. In all terms, we have 10 to negative 9 over 10 to negative 2, which gives 10 to negative 7. And negative 4 over 4 is negative 1. Negative 3 over 3 is negative 1. And 5 over 5 is positive 1. Now we can take term 10 to negative 7 outside the parenthesis. In the parenthesis, we are left with negative 1. As a result, we obtain the electric potential at the origin due to these three charges as negative 8.99 times 10 to 2 volts. B. How much work you must do if you are to bring a fourth charge of negative 1 nanocoulomb from infinity to the origin? At infinity, the electric potential is 0. So you must do the work to bring Q4 from infinity to the origin, Q4 times VO. With the numerical values, we obtain the work as positive 8.99 times 10 to negative 7 joules. C. Consider again only the three charges in the figure. How much work is required to move the 5 nanocoulomb charge from its current position to infinity? In this part, first let us find the electric potential due to charges Q1 and Q2 at point P. The potential due to Q1 at point P is KQ1 over R1 prime. Now R1 prime is 3 centimeters. And the potential due to Q2 at point P is K times Q2 over R2 prime. Now R2 prime is 4 centimeters. As you see, K is common to both terms. Now we can insert the numerical values into this formula. Again, 10 to negative 7 is common to both terms. Therefore, we can write negative 8.99 times 10 to 2 times 4 over 3 plus 3 over 4. the simple calculation in the parentheses gives us 25 over 12. Therefore, we obtain the potential at point P due to charges Q1 and Q2 as negative 1.87 times 10 to 3 volts. Applied work has the formula the charge Q3 times the potential at infinity minus the potential at point P. At infinity, the potential is 0, so we obtain negative Q3 times Vp. We put the numerical values into this formula to obtain approximately 9.35 times 10 to negative 6 joules. Okay, that's all about this problem. Thank you for your attention. See you in the next video.